Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on November 12, 2025, about 2 days ago. This paper proposes a closed-loop, model-aware training pipeline for tool use, where an 8 billion model surpasses its 32 billion data generator and sets state-of-the-art on BFC LV3 and AceBench at its scale. The paper is titled LoopTool, Closing the Data Training Loop for Robust LLM Tool Calls, and as we'll see later, the implications for model training are quite significant. Also, the author shared a GitHub repo. You'll find a complete codebase to generate seed dialogues for your own toolset, transform them into training data, and train with GRPO via RL. It includes dialogue generation tools, GRPO training scripts, the data loop for GCP, JGLV, and EDDE, plus setup, filtering, and evaluation utilities. So Figure 1 shows the end-to-end closed loop that turns tool calling failures into better training data and a stronger policy. The top strip builds a seed set by synthesizing APIs with a dual tree planner and multi-agent dialogues, which ensures realistic calls. The main loop then interleaves GRPO optimization, capability probing, judge-guided label verification, and error-driven expansion, so supervision improves as weaknesses surface. Data and policies circulate back into the next round, which keeps the model focused on hard, verified cases. Alright, Table 1 makes the core point. The 8 billion model lands near the top of the BFC LV3 leaderboard, signaling robust tool use without relying on closed services. The table reports an overall accuracy of about 74.9. Single-turn non-live abstract syntax tree accuracy reaches about 89.5, and live execution sits near 84.7. Multi-turn overall is roughly 50.9, yet the model still outranks larger baselines like the 32 billion Q one. Well, Table 2 benchmarks tool calling across AceBench and shows where the 8 billion model stands overall. The highlighted row reports an overall score near 73, with balanced gains in single-turn, multi-turn, and special categories. These columns cover practical facets like similar API preference, which checks if the model chooses the right function when interfaces look alike. Compared with other open-source models, the method ranks near the top because it stays competitive across all categories, including agent tasks. Okay, Figure 2 shows that iterative training steadily lifts both category scores and overall accuracy, while the static setting lags. The solid line climbs across 4 rounds, reaching about 75. The dashed line rises more slowly under the same number of steps. The colored bars indicate non-live, live, and multi-turn gains that track the same upward trend. Overall, without iterations means training only on the fixed seed set, which quickly saturates. So Table 4 tests which parts of the loop actually matter, and the message is that every piece pulls its weight. High PPL selection, which flags near boundary cases by high perplexity, lifts multi-turn accuracy to about 49. JGLV, the judge-guided label verification, prevents drops because it cleans wrong annotations. EDDE, the error-driven expansion, adds hard variants that raise overall accuracy to about 74. The strongest rows come from D2 and D3 with all modules on. Wrapping up, 2 takeaways stand out. Closing the data training loop with capability probing, judge-guided label verification, and error-driven expansion delivers steady, verified gains, and an 8 billion model can outperform its 32 billion data generator. The broader implication is practical and open. Self-correcting pipelines, reduce reliance on closed services, and make robust tool use scalable. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.